In this video, we're going to go back and we're going to look at probability again, except this time for calculating probability, we're going to go in and we're going to look at calculating probability from a normal distribution. The reason for that is that many of the variables that we run into as business analysts are normally distributed. We know the average, we know the standard deviation of it, and from those two things we can calculate probabilities that are that may be important to us as we work through our decision-making process. So again, what we're really looking at here from a probability standpoint is what's the chance that something is going to occur. It's a very big business concept. And if we can take the normal distribution and we can come up with a way to draw a picture of the scenario, we can take the average and the standard deviation using Excel to come up with to calculate the probability that something's going to happen. Quick review. Here's the normal distribution. You also may know of it as the bell curve. And what happens in the normal distribution is along the x-axis is the average. All right? So whatever the average is in the center. And the y-axis is the percentage of events that occur based on the value along the bottom. Normal distribution, the highest point is at the average. All right, so this is what occurs most frequently. And as we move further away from the average this way, we drop down to where we get down to almost 0% or out here. This is symmetrical, so it's shaped exactly the same way on the other side. Also in this distribution, we know that if we go out one standard deviation on either side of the mean, we capture approximately 68% of all of the values. Similarly, if we go out a second standard deviation from the mean, we capture a little over 95% of all of the values. So let's take this graphic approach and go in and be able to solve problems. Problem in the book, the Jaggi et al. Textbook, Business Analytics, says that let's assume that we have a mean of 72 for an item, an average of 8. And this is for a manager's aptitude test. All right, so the managers have taken this test. 72 is the average, 8 is the standard deviation, and we want to find out what's the probability that a manager would have scored greater than 60 on this test. First step is to draw a picture. Draw the curve, put in the average, all right? Draw the 60, which is what we're interested in, and shade in the area that you're looking at, all right? Now, using Excel, the function norm.dist needs 4 different arguments. It wants the value that you're interested in, the average, the standard deviation, and true or false. True means to give the cumulative amount, and so again, that's the cumulative amount above that the place. False means just give the amount that's associated directly with that value. When you type this in to Excel and hit enter, it should return the answer 0.9332. That means 93.32% of all of the managers who take this test scored somewhere above 60. That means that if I go in to take this test, there's about a 93.32% chance that I will score 60 or above. All right, now again, whenever we're drawing pictures, there are really only 4 ways that we can change this picture when using this approach. We can either choose a value and take above this amount, or we can choose a value and take the value below it. Since Excel calculates the percentage above, let's assume that we're really looking for, instead of greater than 60 points on this manager's test, that we're looking at less than. We draw it, we look at the area that we're interested in, and now this time what we're looking for is the area that is in this smaller area. So when we punch in the values that we have, it tells us not for this amount, but for the entire amount. Well, one thing that we know about the normal distribution is that all of this has to equal 100%. So if I take 1 minus this amount that Excel just calculated, it tells me that's what's in the remaining tail over here is a little over 6.7%. All right? That's the second way we can look at things. A third way we can look at it is for a banded area. So let's say we wanted to know what percentage of all of the managers are going to make between a 68 and an 84. Again, using the same setup, we would take, first of all, since the largest value that we're going to get is the 84, we put in equals norm dist for the 84 minus the 68 that we're looking at. All right, last way that would happen is if we were just looking at just the tails, and I think you can figure that one out from there. All right, now let's go one step further here and look at the two tails, and then finally let's look at a cumulative idea where we're looking at the percentile. One thing that oftentimes we do talk about in business is we want to be able to provide at least 90% service on something or 95% service on an item, which means that if we're looking at an average day, we want to make sure that we have enough stores on hand to cover 90% of the amount of demands that we would get in that day. That equates to a 90th percentile. So what we're looking at this point is, in particular on this example, is if I wanted to predict this 90% score, where we can say that only 10% of the managers are going to go above this value, right? So we wanted to pick the top 10%, then we would use a different function called the norm inverse function. In that, there's only 3 arguments: cumulative probability that we're looking at, the average, and the standard deviation. Again, if the mean is 72, standard deviation is 8, and we're looking at the 90th percentile, when we punch this into Excel, we get 82.25. That means that only 10% of our managers are going to score above an 82.25, and that 90% will score less than the 82.25. All right, this is, again, another very good way to look at probability, being able to draw your pictures, put your mark on here for the area that you're interested in, use Excel to calculate the values for you, and then at that point be able to go in and conceptually say, this is the probability to the answer that we're looking for.